It is often said that the world goes in a circle, such that the same states are always reproduced. Therefore, the world could exist forever. The second law contradicts this idea most resolutely. Entropy tends to a maximum. The more closely that maximum is approached, the less cause for change exists. And when the maximum is reached, no further changes can occur. The world is then in a dead, stagnant state. Salt has become a major pollutant of cities in northern climates like our own city of Minneapolis. It is estimated that as much as 60 million metric tons of salt is applied to roads worldwide every year.
In our own city of Minneapolis, we use 35,000 tons of salt per year just to desalt our roads. Along with this, we use 18,000 tons of sand, some liquid magnesium chloride, salt brine, and calcium chloride, along with other deicers.
In fact, chloride concentrations have risen by more than 1/3 in 371 tested North American lakes.
It is clear by this study published by the PNAS that the salt water coming from our roads isn't just going nowhere, it's going into our lakes and streams, and that's a major problem for natural wildlife. The natural consequence of having higher salt concentrations occurs in lakes. Lakes with higher salt concentrations are less likely to turn over in the seasons fall and spring. This leads to less efficient nutrient turnover, creating a dead zone in the bottom of the lake where plants, animals, and other living things cannot survive. Most water treatment facilities in the Greater Twin Cities area use reverse osmosis to clean their water. However, the filter in these reverse osmosis plants are not fine enough to catch salt, hence the salt will stay in our water.
Increased salt concentrations in our drinking water can lead to health problems, such as high blood pressure.
Our solution to this problem is to use natural halophytic plants. These are plants that thrive in a saline environment, aka they like a lot of salt in their soil. The specific species that we're interested in for Minnesota's salt problem is called red saltwort. Red saltwort can survive in up to 70 grams per liter of dissolved salt. That's twice the concentration of salt in the ocean. Our solution to solve Minnesota's and Minneapolis's salt problem is to use rain gardens with these halophytic plants. By strategically planting red saltwort near our roads, we can eliminate salinated water from entering our lakes, rivers, and streams.
A specific system has been designed so that salt accumulates in our rain garden from winter storm melt and is then treated during the summer months. Our red saltwort is planted in the spring grows and is maintained in the summer and is harvested in the fall. Here is our AutoCAD design of our system. We have all of our pipe measurements. We've got a 30 centimeter soil depth, 2 different sites for conductivity measurement throughout the season. We have a max ponding depth of 6 centimeters to prevent our plants from drowning, a geosynthetic clay liner of 6 millimeters to prevent any water from leaving our system and causing salt to go elsewhere. So with any storm event, rain or snow, it'll be accumulating on the impermeable surface of the road and flowing into our gutter. Taking the salt with it if it's in the winter, snow melt. Then this water will flow right into another nearby manhole, which then flows into our system. So right into our rain garden, the water will seep into our soil, nice silty soil for our plants, and some of it will pond and accumulate in the middle. And we have a little drainage pipe at the bottom for any excess sitting water and a little valve to let it through. If we have a large storm event with a lot of water, we'll have a lot more flowing into our system, so we have a nice little overflow system designed to prevent any flooding and drowning of our plants. And this overflow goes to a nearby pond. So we've got a lot more water going into our system, so here is our secondary overflow prevention, which is a nice little pipe in the middle, which also goes to the nearby pond. Red saltwort is an annual plant, so to prevent the salt from returning to the environment, it is harvested. Red saltwort also has many potential uses. It can be used as animal feed, it is edible to humans, and it can be used to make biofuel. This is the current cradle-to-grave cycle of salt we see today. Salt is harvested as a raw material, is then applied to our roads, runs off into our roadside ecosystems, into our watersheds, streams, and lakes. Our system could create a cradle-to-cradle cycle. Imagine not having to use fresh water to irrigate your crops. Fresh water is an incredibly valuable resource, and it takes a lot of water to irrigate an entire field. A company called Salt Farm Texel has developed a potato that is able to withstand high levels of salinity in its soil. Salt-tolerant agriculture is helping farmers in Bangladesh. Farmers can grow healthy crops in their saline farmland, thereby giving healthy food and income opportunities to these families. The coastal areas of Bangladesh cover more than 30% of cultivatable lands of the country. About 53% of these areas are affected by soil salinity, a major risk from climate change. Salinity causes unfavorable conditions, restricting normal crop production throughout the year. A study conducted by the World Bank in 2015 projects a median increase of 26% in salinity by 2050, with increases over 55% in most affected areas.
Red saltwort can have other far-reaching effects. We can use other halophytic plants, like red saltwort, to create genetically modified crops. This would save an outstanding amount of fresh water that's currently wasted on irrigation.
With these kinds of advancements in technology, we'll be able to provide food for a massively growing population and provide fresh water. Seawater and natural saline environments are underutilized resources that could make a huge impact on reducing the effects of climate change. In conclusion, we need to utilize our resources, whether it be natural seawater or salt flats, or even human-caused pollution of road salt. Salt is a resource, and it needs to be treated as such. It can become an asset rather than an environmental liability.